All right, one more video on gas stoichiometry. Let's see how we do here. So we're told 35 grams of zinc is reacting with 8.2 grams of hydrochloric acid. Now, just don't go any further than that. If you've done stoichiometry, that's jumping out at you as looking like a limiting reagent kind of question, right? When you know how much of one reactant, 35 grams of zinc, is reacting with another amount, in this case 8.2 grams of another reactant, HCl, that sounds like a limiting reagent question, and I'm kind of groaning at that. The hydrogen gas produced is collected over water. Well, we've seen in other examples, when you collect gas over water, Dalton's law kicks in. The total pressure of the gas being collected is the pressure of hydrogen, what we're producing here, plus the pressure of water vapor, which is evaporating from the water that we're collecting over. So that's a little warning sign. We may have to use Dalton's law. What volume of hydrogen gas could be collected at this temperature and this pressure? So this is looking right there like an ideal gas law question. Volume, temperature, pressure, and that's an ideal gas law question. But that pressure, 745 torr, that's not the pressure of our gas. That would be the total pressure, the pressure in the room. And then at the end, it gives us the vapor pressure of water at that same temperature. So let's jump in and see what we can do. This is a stoichiometry problem, so we need a balanced equation. The zinc metal is reacting with the hydrochloric acid. Well, from our stoichiometry unit, that looks like a single replacement reaction, and the zinc will end up with a charge of 2 positive. I know that from page 6 in my data booklet, the chart of the ions. And then chloride's charge is -1, so one of the products would be zinc chloride, and then the hydrogen comes out as the element hydrogen, but that's a Hofbrinkel element, it's diatomic. We need to write H2. To balance the equation, we put a 2 there. So now we have a balanced equation. We recognize that we're going to need the ideal gas law to find the volume of the hydrogen gas. So let's write that. PV is nRT. So V, the volume of the hydrogen, would be, let me put a little subscript there, volume of hydrogen. It'll be the moles of hydrogen times R times T divided by the pressure of the hydrogen gas. You don't need to put those subscripts, but it's kind of helpful so you don't confuse, moles of what and pressure of what. It's the moles of hydrogen, pressure of hydrogen, temperature of hydrogen also, so that we get the volume of the hydrogen. Now, looking at the question, what do we know for the ideal gas law? Well, we know the temperature and we know R, but we don't know the moles of hydrogen and we don't know the pressure of hydrogen. Well, you might say there is a pressure, 745 torr, but that pressure was the total pressure the pressure in the room. And when you collected the gas by water displacement, the pressure of the mixture of hydrogen and water vapor is equal to that total pressure of the room. So let's use Dalton's law on the side here. Dalton's law, because we're dealing with pressures of a mixture of gases, the total pressure, the pressure in the room, would be the pressure of hydrogen that we're interested in, plus the pressure of the water vapor, which is mixed with our hydrogen. That's because we're collecting by water displacement. So the pressure of the hydrogen, the thing I need for my ideal gas law, is the total pressure minus the water vapor pressure. So that's going to equal 745 minus 21.1 torr, right? I got those numbers right from above. So that's going to give me, let's see, 745, 725, 724 torr. But we can't use torr in the ideal gas law. We're going to have to convert that. You can convert that to either atmospheres or kilopascals. All right, so convert to atmospheres or kilopascals. Once you have that calculated, then we would know the temperature of the gas, we would know R, we would know pressure of the gas. The value for R, of course, would match the units for the pressure. If you're using atmospheres for the pressure, then R is 0.0821. If you're using kilopascals for pressure, then R is 8.314. So now how do we get the moles of hydrogen? Looking back at the question, the thing we haven't yet used was that scary bit at the beginning, this is a limiting reagent question. Now, you've told me the mass of zinc, you've told me the mass of HCl. I need the moles of hydrogen gas being produced. So that tells me we need to do stoichiometry. But here, it's a limiting reagent question. We need to figure out which of those reactants was limiting. So to first find the limiting reagent, we would pick one of those. We'll take 35 grams of zinc, and we're going to calculate how many grams of the HCl did I actually need to react with this. So we would convert the grams of zinc to moles of zinc, use our balanced equation, convert moles of zinc to moles of the acid, and then because the question told us grams of HCl, we'll convert the moles of HCl to grams of HCl. So this is going to tell us this many grams of HCl are needed. I'm not actually going to calculate that for you. You would do that yourself. So you can pause here and try it. Now, assuming you've done the calculation, you know how many grams of HCl are needed to react with your zinc. Compare that to how many grams of zinc we have up above. We have 8.2 grams, how many grams of acid we have up above. We have 8.2 grams of the HCl. So if you suppose you needed 5 grams of HCl, well then you'd say we have 8.2, we have excess. So HCl would not be limiting. Suppose you calculated we would need 10 grams of HCl. Then up above you'd say, but we only have 8.2 grams. So HCl, we don't have enough. HCl would be limiting, right? So from that answer, you can figure out whether the HCl is limiting or whether the zinc is limiting. So once you've got the limiting reagent, you would then use the limiting reagent in a similar set of unit multipliers. Start with your limiting reagent, convert the grams of limiting reagent to moles, convert that to moles of hydrogen using the balanced equation, and now you can put that moles of hydrogen, so you're going to convert that to moles of hydrogen, and then take that and put it in your ideal gas law, and we're done, right? We have the moles of hydrogen from our stoichiometry, we have the temperature from the question itself, the pressure we got from Dalton's law. Now we can go ahead and calculate the volume of the hydrogen using the ideal gas law. All right? So as I said in another video, this is not a question where you should try to memorize the steps. Instead, I hope as you followed with me, you saw the steps just kind of unfold. You could have done this in a different sequence. You might have done the stoichiometry first and then realized you need Dalton's law and then jump to the ideal gas law. But you needed to see these different steps unfold in front of you, partly because as we read the question, we were prompted, we're probably going to do a limiting reagent calculation. Oh, I see it's being collected over water, and there's the vapor pressure of water. I'm probably going to use Dalton's law. So those are visual cues as well that can help. So I hope that helps understand how to do a gas stoichiometry question. This would be one of the hardest you might ever encounter with limiting reagents. If you're studying for a test, realize on a test I would much more likely break a question down into steps. I would prompt you to calculate the pressure of hydrogen. Then I would in this question I would have prompted you to find the limiting reagent, prompt you to find the moles of hydrogen, and at the end I would have prompted you to find the volume. I would not have just asked you to create all this on a test situation. So I hope that helps. Good luck.